recording, we're going to talk about mixed strategy Nash equilibrium. So let me write the definitions for pure strategy and mixed strategy in a very layman language, first of all. And then we will solve this game for mixed strategy Nash equilibrium, right? Okay. So there are two players, player one and player two. Player one also has two choices, hawk and dove. Player two also has two choices, hawk and dove. Now, if we are thinking that when player one is making a choice hawk, so he's playing only hawk, right? He's making a choice and he's sticking to it, right? In a way. So that is something like the pure strategy Nash equilibrium or pure strategy. If I can say that 50% of the time player one is going to play hawk, 50% of the time player one is going to play dove, 30% of the time player two is going to play hawk, and 70% of the time player two is going to play dove. That is a mixed strategy Nash equilibrium, right? So you're randomizing those strategies, right? So that's what the mixed strategy Nash equilibrium. So what we are doing is that up until now we've been thinking about the players making a choice for a strategy once and for all. So each agent makes a choice and he or she sticks to it. So that's what pure strategy is. Mixed strategy is that you are randomizing these choices. So let me write that first and then we'll look at it. So each agent is making one choice and sticking to it, right? That is what would be pure strategy. That is what would be pure strategy. That is, I mean, if you are playing hawk, so you're playing hawk with probability one, right? That is, so it's 1-0, right? So you're playing hawk only, or you're playing dove. So you're making one choice and you're sticking to it. So this is what is pure strategy. A very rudimentary definition, right? It's not a formal definition. Well, if you allow agents to randomize these strategies, right? That is, you assign a probability to the choice, and people are going to play according to those probabilities, right? That is what mixed strategy is. So if we allow agents to randomize these strategies, that is, to assign a probability to each choice and to play according to these choices, right? And to play according to these to their choices, right? To play, it is to play their choices according to these probabilities. According to these probabilities. So maybe, I mean, 50% of the time player one is going to play hawk, and 50% of the time player one is going to play dove. 30% of the time player 1 is going to play hawk, and 70% of the time player 2 is going to play dog, like that. So that's what mixed strategy is. So this kind of strategy is called mixed strategy, right? So this kind of strategy is what is called mixed strategy. So how do you write this? I mean, pure strategy. Okay, let me just write it like this. Let's look at this game. Hmm. Let us say player 1 is going to play hawk with probability p, and since there is only one more what do you call strategy here, so if he's playing hawk with probability p, he'll be playing hawk dove with probability 1 minus p, right? Player 2 is, let us say, going to play hawk with probability q, since there are only two strategies. So if player 2 is going to play hawk with probability q, so he'll be playing dove with probability 1 minus q, right? uh, Hawk with probability 1 minus q. So acha, you tell me one thing. Now pure strategy is going to occur when either p or q is going to be either 0 or 1. So if p is 0, it means 1 minus p is 1. If q is 0, it means 1 minus q is 1. So that is pure strategy is going to occur when you have either 100% to this, 0% to this, or 100% to this, 0% to this, right? So you might also write that as well. Pure strategy occurs when p or p and q are equal to 0 or 1, right? 100% probability or 0% probability. So for mixed strategy, let's think about it. Now you just think about it. So player 1 is playing hawk with probability p and dove with probability 1 minus p. Player 2 is going to play hawk with probability q and dove with probability 1 minus q. Right, fair enough. So how do you go about this? Can you just think of, supposedly if I'm player 1 and you are player 2, right? If I play hawk, I will be getting 0 as the payoff if you play also hawk. Otherwise, if I play hawk, I can get a payoff of 6, but depending on whether you played dog. Are you with me? When I play hawk, I can get a payoff of 0 if you play hawk and you are playing hawk with probability q. When I play hawk, I can also get, I can either get payoff of 6 when you play dog and you play dog with probability 1 minus q. So my utility from playing hawk, it depends on whether you are playing hawk or dog. So whatever payoff I'm going to get, that will be the expected probability of that, right? So how do I write this? How do I write this? I can write it like this. My, I am player 1. My utility when I am playing hawk, right? Of course, it depends on whether you play hawk or dove. So my payoff is 0 when you play hawk, and this is when I'm playing hawk beta. Okay. My payoff is 6 when I'm playing hawk, provided, and this 6 would be there if you play dove. So my payoff from playing hawk is 6 provided you play dove. You with me? Similarly, my payoff from playing dove, given your probability, is when I play dove, right? Whether I'll get 1 or 3 depends on whether you play hawk or you play dove. So I will get 1 if you play hawk and you play hawk with probability q. This is when I'm playing dove. So I get 1 when you play hawk. I get 3 when you play dov, and you play dov with probability 1 minus q. Right, beta? Mm-hmm. So this is there. Now you tell me one thing. So this is what? Q plus 3 minus 3q. That is 3 minus 2q. This is 6 minus 6q. Okay, fair enough. When do you think I'll be playing Hawk? When the utility which I get from playing Hawk is more than the utility which I get from playing Dog, then only I will be playing Hawk. So player one would play Hawk when utility which player 1 is going to get from playing Hawk is more than the utility which player 1 is going to get from playing Dog. Is that right? So beta, it is what? 6 minus 6q when it is greater than 3 minus 2q. So in that case, I'll be playing Hawk. I'm player 1. I'll be playing Hawk in this case, right? So what will this be? So if you'll just calculate this, this is going to come out to be what? Your Q less than 3 by 4. Q less than 3 by 4. Are you getting this? So when your probability, what is Q? Q is you guys are player 2, I am player 1. So if your probability of playing Hawk is less than 3 by 4, I will surely play Hawk. That is what the idea, right? So if your probability of playing Hawk, Q less than 3, Q is what? Q is your probability of playing Hawk. So if your probability of playing Hawk is less than 3 by 4, then in that case, I will surely play Hawk, right? I will surely play Hawk. So what do I mean by this? I mean by this. So you have P and Q. This is, of course, these are probabilities. So they can be somewhere between 0 and 1 only. Let's say this is 3 by 4. So beta, when Q is less than 3 by 4, I am surely going to play Hawk. That is one. You getting what I'm saying? What am I doing? Ikbar, let's look at it once more. If Q is less than 3 by 4, the utility which individual 1 gets from playing Hawk is more than the utility which individual 1 is going to get from playing Dove. So he'll be playing Hawk only, right? So he'll surely play Hawk. That means P is equal to 1. Just think about it. When Q is less than 3 by 4, P is 1. For all values of Q less than 3 by 4, P is equal to 1. You with me? Mm-hmm. Okay. This is first point. Second, player 1 would play Dove when utility which player 1 is going to get from playing Hawk is less than the utility which player 1 is going to get from playing Dove, right? Given the probabilities which player 2 is going to. So, I mean, basically, I am player 1 and I'll be playing Dove when my utility is going to be higher from playing Dove than from playing Hawk. So it is what? 6 minus 6q is less than 3 minus 2. Think about it. So if your probability, you guys are player two. If your probability of playing hawk is more than 3 by 4, means 75% of the time you will be playing hawk, then it is better for me to play dove because my utility from playing dove is more. And you think it intuitively also. If you are surely going to play hawk, I mean 75% of the time, more than 75, means let's say Q is 90%, means you are going to play hawk 90% of the time. Now I know he will be playing hawk only, so I'll have to compare between 0 and 1. So 1 is higher, so I'll be playing dove now. That's what it is. So, and when I play dove, for sure, that is when your probability from playing hawk is more than 75%, then my utility from playing dove is more than my utility from playing hawk. So I'll be playing dove only. So if I'll play dove, so it means probability of playing hawk is 0. So I mean basically what I mean is that 1 minus p is equal to 1. This probability is 1 na, playing dove. But 1 minus p equals to 1 means what? P is equal to 0. That's what it is. So having said that, how do you write this? So when q is greater than 3 by 4, beta, ta, 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 this is going to be there. P is going to be 0. When q is greater than 3 by 4, P is going to be 0. Hello? Hmm? And third, player 1 would be indifferent between playing hawk and dove when the utility from playing hawk is equal to the utility from playing dove. Hmm? So it is what? 6 minus 6q is equal to 3 minus 2q. Q is equal to 3 by 4. Q is equal to 3 by 4. Right, beta? So when Q is equal to 3 by 4, I mean, whatever. I'm indifferent between playing hawk or dove. I'm indifferent between playing hawk or dove. You with me, beta? This is what it is. So when Q is 3 by 4, it could be anything. 0 or 1. I'm indifferent. I can play hawk also. I can play dove also. Whatever. So I don't know. So I'm indifferent between them. So what is it that we have drawn? This is the best response function of player 1. Depending on the probability of playing hawk by player 2. Are you with me? So how do you write these best response functions? So best response function of player 1 depending on probability of playing hawk by player 2. So when q is less than 3 by 4, how do you write? When q is less than 3 by 4, it is 1. That's what we have drawn. When q is equal to 3 by 4, you are indifferent. When q is greater than 3 by 4, it is 0. You with me? I'm sure you would have understood. I hope so, right? Then what about dove? Oh, sorry, what about player 2? The same thing for player 2 also. Just think about it. So player 2 will get the, in case a player 2 is going to play hawk. Now player 2 can get 0, player 2 can get 6. So player 2 will get 0 if player 1 is going to play hawk. Player 2 will get 6 if player 1 is going to play dove. You with me? Player 2 can also play dove. So the utility from playing dove, it could be 1 provided player 1 plays hawk. Utility from playing dove could be 3 provided player 1 plays dove. You with me? So how do you write this? The same thing. Same thing. So player 2 would play hawk when utility from playing hawk is more than the utility from playing, sorry, from playing top. Guys, think about it the way I've written. Player 2's utility from playing hawk when player 1's probabilities are given, right? There we have written u1 hq, u1 dq. Here we are writing u2 hp, u2 dp. Okay. So what is this? Hmm. What will this be, beta? Utility from playing hawk is 0 provided player 1 plays hawk. So P into 0. Utility from playing hawk is 6 provided player 1 plays dop 1 minus P. So it is 6 into 1 minus P. So how do you write this? How do you write this? That is 0 into P plus 6 into 1 minus P greater than U2 dP, that is utility from playing dove is 1 provided player 1 plays hawk. Utility from playing dove is 3 provided player 1 plays dove. Right? So it is what? 1 into P plus 3 into 1 minus. Right? So when you just solve this, you'll be getting P less than 3 by 4. So if player 1 is going to play, player 1, think about it. Player 1 is going to play hawk with less than 75% probability, right? With less than 75% probability. Then less than or greater? Yeah, less than 75% probability. It is better for player 2 to play hawk. It is better for player 2 to play hawk, right? And so please write this similarly. And how do you write this? And player 2 would play dog when utility from playing hawk is less than the utility from playing dove. So what is that for? So what is that? Your 6 minus 6p less than 3 minus 2p, p greater than 3 by 4. So if the probability that player 1 is going to play hawk, if this p is greater than 75%, right? So he's going to play hawk more. He's going to play hawk more. Then between 0 and 1, you should choose what one? So you should be playing dove. When P is less than 75%, so I mean, you can think of probably he's going to play this more. So between hawk and dove, between 6 and 3, you should be choosing 6. That's an idea. So that's what it is. And player 2 would be indifferent between hawk and dove when the utility from playing hawk is equal to the utility from playing dove, right? So that means what? 6 minus 6p is equal to 3 minus 2p. P is equal to 3 by 4. P is equal to 3 by 4. So if you just want to draw this on this diagram, so you have 3 by 4 here also. Da, 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 da. Now just think about it. So Q is 1. Okay. So when P is less than 3 by 4, here, when P is less than 3 by 4, what is it that you have done? Player 1 is going to play hawk. Sorry, player 2 is going to play hawk. So if P is less than 3 by 4, player 2 is going to play hawk. And player 2 is playing hawk with probability Q. Right? So Q is equal to 1. Hello, hello, hello. Tuck, 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 tuck. You might have to do this once or twice. Fair enough. Then if P is greater than 3 by 4, then he is better off playing dove. So the probability of playing hawk is 0 there. So this is there. You know, this one. And if P is equal to 3 by 4, player 2 is indifferent between playing hawk or dove. Player 2 is indifferent between playing hawk or dove. So this is what? The best response function of player 2 given the probabilities with which player 1 is playing. So how do you write the best response function? Sorry, I'm just writing it here only. Best response function of player 2 given the probabilities of this guy. So how do you write this? If P is less than 3 by 4, it is going to be equal to 1. If P is equal to 3 by 4, it is going to be equal to 0, 1. If P is going to be greater than 3 by 4, it is going to be equal to 0. Have it up, right? So where these two curves intersect, and where do they intersect? Here, right? They intersect it here. They intersect here. So this is what is the mixed strategy Nash equilibrium. This is what the mixed strategy Nash equilibrium is. That is what? Beta, P is what? 3 by 4. Q is what? 3 by 4. Huh? They're also intersecting here. This one is a pure strategy Nash equilibrium. When is pure strategy Nash equilibrium? Either P or Q is 0 or 1, right? Pure strategy Nash equilibrium. So what is this? P is 1, Q is 0. They're also intersecting here. Is also pure strategy Nash equilibrium. So this is P is 0, Q is 1. P is 0, Q is 1. Right, beta? So here there are two pure strategies, pure strategy Nash equilibrium, and here you have the mixed strategy Nash equilibrium, 3 by 4, 3 by 4. You can also look at the pure strategy Nash equilibrium if you want. So if I play hawk, I'm player 1, you guys are player 2. If I play hawk, then you will be comparing between 0 and 1. You should be picking up 1. If you play dove, I should be comparing between hawk and dove, that is 6 and 3. I should be playing this. Right? Right, beta? So P is 1, Q is 0. So P is 1. So I'm playing hawk and you are playing dove. So you're playing dove with probability Q 0. Right? Okay. If I play dove, you'll be comparing between 6 and 3. You should be getting 6. If you play hawk, I'll be comparing between hawk and dove, that is 0 and 1. I should be playing this. That is this. So it is, I'm playing dove with P0 and you're playing hawk with Q1. So these two are pure strategy Nash equilibriums. Are you with me, beta? Right? So I hope you have understood this. How to find out mixed strategy Nash equilibrium. Thank you, beta.